Okay, we're on it. All right.
All right.
You guys ready?
Hang on. Okay. So there's 31 questions. Wow.
Wow, they want us to get it in.
Yeah.
Okay.
Is this the group quiz?
Yes, so we're going to go to the Lesson 8 group quiz.
So are the same questions for the preparation assignment, I think?
Oh,
Yeah, they're all the same. I think that's what it said, but
Yeah. No.
questions.
hang on, I'm just opening up this thing. Oh. Okay. Let's. So we were supposed to take this once before we met together?
Were we?
I don't know, that's what it says. Well, I guess we'll do it together. Okay.
I didn't.
I didn't either. I just went through the questions on the review on here.
Okay.
They're all the same, and that's why it says that.
Yeah, probably. Okay. So who wants to read?
I can.
Thank you.
Okay. So, which of the following, well, number 1, you do yourself. Number 2, which of the following variables is our categorical? The number of animals in the local zoo, a randomly selected brand of toothpaste at a convenience store, age and years of randomly selected vehicles in a parking lot.
I think it's B.
Toothpaste.
Yeah.
That's what.
I am not sure if it could also be C though. Age and years around such a vehicle in the parking lot.
Years.
If you are categorizing them by the year they were, yeah, that would also be categorical.
No.
Brand of toothpaste in the age and years, I think.
Well, can we select more than one? Yeah, we can. So yeah, I think also the number of animals in a local zoo.
That would be numerical.
That would be that's quantitative, yeah. So
So age and years.
So
Okay, so we can pick. Oh, okay. All right.
B and C, you think?
So B and C.
Yeah.
Okay, number 3. The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their score was 112. Which of the following statements are true? 100 is a parameter, 112 is a parameter, 100 is a statistic, and 112 is a statistic.
Isn't the parameter the mean, 100. The 100, and the 112 is the
Statistic.
statistic.
Yes.
The first and last.
Yeah.
3.
Yeah.
Okay.
Okay.
Question 4. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sampling should we collect to gauge the residents' responses to a proposed increase in property tax? A simple random sample, systematic sample, cluster sample, or stratified sample? I think stratified.
Yeah.
Yes.
I get those two mixed up sometimes.
Which
two? The cluster and the stratified.
So cluster is you're going to come in, you're going to grab a random group, and you're going to test every single participant in that group. Whereas stratified, you're going to say, here's low poverty or property values. Here's high property values. We're going to take a couple from the high, a couple from the low, and a couple from a couple groups in between.
Yep.
Does that make sense?
Yeah, so say again for the cluster sampling.
So the cluster
What did you say?
sampling, you're going to take a random group, and then you're testing everybody in that group. Whereas stratified,
Just a random group.
you're taking several groups, and then you're pulling from those several groups a little sample out of each.
Okay, that makes sense.
So since we have like a high property tax values and then very low property tax values, we're probably going to get from a little bit of all of the group. All right. Are we good with number 4?
Yeah.
Okay. Question number 5. When designed experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? A simple random sample, voluntary response sample, a systematic random sample, a stratified random sample, and a cluster sample. I would say cluster.
I think it's cluster.
Because they took all 4th grade students in that district.
Mm-hmm.
I think that's right.
I think it might be a stratified random sample. Isn't that when you take people of the same, like they have something in common, all of them?
They do, but this is grabbing, so what they did is they grabbed all 4th grade students. So one big group, and they tested all of those instead of grabbing from like, say, 4th grade, 5th grade, 6th grade, 7th grade, and grab a couple out of each of those grades. They did just 4th grade.
Mm-hmm.
Does that make sense?
Yeah.
Okay. All right.
Okay.
All right, number 6. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented?
A simple random sample?
I think so.
Yeah.
Because it's like just pulling names out of a hat, and I think that's what that is.
Mm-hmm. The other ones. Mm-hmm. 6 names were selected to receive. I think it's the.
Sorry, guys. Okay, I'm back. All right. So what
I
did you?
think that's right.
Yeah, I think it's A. First one.
I think it's A.
Mm-hmm. It says
For number 7?
6, right?
Oh yeah, 6 is A.
right. Mm-hmm.
Yeah. Okay. 7.
Sorry, guys. Hold on one second.
Okay.
Love you. All right, go to bed. Sorry, we're going to bed. All right. Question 7. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers picked a list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of the registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented?
So they divided them into 2, or they had 2 groups, and then
Mhm.
they did a simple random sample.
Of each of the groups. So
Yeah.
I would say stratified.
Stratified, that's what I think.
That's what I think too. Mhm.
Yeah.
Okay.
Okay.
You guys
so
good?
Question 8, you need to click on the XLS file
Okay.
and answer for the next 3 questions.
Where am I? Okay. Crossroads. The mean of the amount spent. Amount spent. Okay.
Okay. Okay, guys, so using the software, calculate the mean of the amount spent. Round to 3 decimals. Let me get mine to come up.
Hey, wait a second. Then we have to open up that other.
Yeah, from your notes, you're going to have that other.
Yeah, what is that called? Yeah, I know. Can't remember the name of it. Hold on. Quantitative something.
I'm getting there.
Is it quantitative, descriptive?
Hang on. Yeah, the quantitative descriptive statistics.
Yeah.
I think that's it.
Is that in lesson 3, guys? Thinking it is.
I downloaded it, so I have it on my computer. I can't remember what
No,
lesson.
We're working off computers.
Yeah.
Okay. There it is.
Okay, found it. Okay.
Mhm.
Okay, so Give the mean, standard deviation, and 5-number summary.
So this is the mean, and it's Excel document. So I did auto sum, and then I divided it. I just calculated the average, and it's 4.77.
Yeah.
Yeah, I got the same.
I got the same too, yeah.
It says 3 decimal places, so 4.771.
71. Uh-huh.
Okay.
Standard deviation, 1.912.
Wait, you guys, 4.771?
Yeah.
Yeah.
Mm-hmm.
Is that what you got?
Yes. Right. Using the software, calculate the standard deviation of the spent amount.
And 5-number summary. So that's the minimum. Are you guys all using your little thingy in Excel?
Yeah.
Yeah.
I'm going to take this.
So did you guys pull it all up?
Yeah.
So
So what did you get for standard deviation?
what's that?
What did you get?
So it's 1.912, I guess, if we're
Yeah.
raising that.
Yeah, that's what I got too.
And then the minimum is 0.84. Q1 is 3.42.
Mm-hmm.
Medium 5.15. Q3 is 5.61. And the max is 10.45.
Yep.
That's the same.
Sorry, guys, it's taking me a little while to get it rolling.
Yeah, don't worry. Mhm.
Okay, there we go.
On the next one, it says you have to create a histogram. That,
So it should already have been created, right?
Oh, we're only supposed to calculate the mean?
Okay, guys. On the standard deviation, did you get 1.911 or 12, I guess?
1, 2, yeah.
1, 2. Yeah.
Okay. Mine's now working. I'm
The
fine
quest-
coming to the party.
Okay. Okay.
Oh, the standard deviation, okay.
Okay.
So
So
we are supposed to round up, right?
yes. So it
Yeah.
says round to 3 decimals.
So 1.912
Yep.
Yeah.
for question 9, okay.
So question 10. Start by creating a histogram of the amount spent in Crossroads purchases. Then mark the following statement as true or false. So I created a histogram representing the amount spent in Crossroads purchases. If you guys use that, whatever Excel
Yeah.
spreadsheet.
It's right there.
Yep.
Yeah, it's right there. Okay, true.
All right, so information. Jessica Meyer and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed on the hepatic sinus of 4 of the seals, named Bodil, Roberta, Larry, and Purr. The seal's body temperature at the start of the dive was calculated to be below. Complete the following table and use your work to answer the next 4 questions. So, question 11. What is the value of the number that goes into the position marked with A in the table above? So deviation
A. So first we have to find out
The
The
mean.
mean, right? Of
Right.
those four?
Yes.
So the representative temperature up above.
So I got 38.075 as the mean.
38.075. Mm-hmm. That's what I got.
Okay.
Wait, what did you subtract it from? Where's the standard deviation? Is it 10?
I think, I don't know, I could be wrong, but I thought don't you take the, now I gotta think. You take the first number, which is 37.91, and subtract the mean, which is the 38.075
Yes.
to get A.
Mm-hmm.
Is that correct?
Yeah.
Yeah.
Because that's what I figured out. So I got, what did I get? Negative 0.165.
Yeah.
Wait, what did you guys get for your mean?
I got
30.075.
Okay, I gotta recalculate. Hold on. Okay, now it works. Okay, 38.075.
Mm-hmm.
Okay. I got like some random number like 123. I knew that wasn't right. Okay. Sorry. And then you subtract.
The first
Okay, so
value.
37.91 and then
Mhm.
subtract
Minus.
the mean.
Mm-hmm.
What you guys did. You got. Negative 0.165.
That's what I got.
Okay.
Yeah. 0.165. Yeah.
Yeah. Okay.
And then you square that number, right? To get the standard square deviation.
Right.
So we got to find what goes in B. So we do the same thing with the 3725. And I got negative 0.825 for the second box.
I think it's not asking for it.
No, but we got to find out the letter B, what that number is.
It's not the same as Bodil's. So they're asking
Right.
for Roberta, not Bodil.
Right.
So
So you
use the same
take,
number.
huh?
And so I'm just explaining we can't use this for the same number that we used for A.
Right, right. So
Use
you have to take
a
the
different
37.25
Mm-hmm.
minus 38. So I got negative 0.825
Yep.
Okay.
for the first box, or the deviation from the mean.
For number B? No, no yet, right?
No, for A.
Okay, for A. Okay. Mm-hmm.
So for B, I don't know if I did this right, negative 1.65.
I got 0.681.
Yeah,
Oh,
I got
geez.
that one. 0.681.
Yeah.
I got one.
Good one.
I got 1.381.
Oh my gosh.
So did you take the negative 0.825 and then square that?
Isn't that just, I couldn't figure out how to do it on my calculator.
Oh,
What did you guys get for number 11?
Number 11 is negative 0.165.
Okay.
Mm-hmm.
So now I'm trying to figure out B. Okay, so I got the negative 0.825. Now this is a dumb question. So on my scientific calculator, if you put that in 0.825,
You put negative.
yeah.
Okay.
So which is the button you do to square it?
It's going to have X.
Oh, I see it. It's the X with the 2, right?
Yep.
Okay, so 0.681.
Yes.
Is that right?
Yep.
6.1.
Wait,
0.681.
Okay.
you need to explain to me how you got that.
Okay, so we took so we took Robida's temperature of 37.25,
Yeah.
and then we subtracted the mean of 38.075. That gave us negative 0.825, and then squared that.
I know what I did wrong. Okay, I got 0.681.
I always need help because I'm like, somehow my calculator always screws up, so I have to put it out in my head.
Did you have to put it in as negative?
For a number 11,
For 11 and 12, because they were both negative, right?
12's not negative, no,
Okay.
but 11 is. I put it as negative.
Okay.
So it's 0.681.
Right.
Is that what you guys got?
That's what I
All
got.
right.
Yeah.
Woohoo. Okay.
Thanks, guys. Okay.
Right, number 13. The quantity is equal to the sum of the numbers in the squared deviations column.
What quantity?
Yeah, what quantity? So the mean, the standard
Oh,
deviation, the variance, or none of these are correct.
It's the variance.
So what quantity is equal to the sum of numbers in the squared deviations column?
I think I put variance, but I wasn't sure why. So if somebody knows, tell me.
It's just the rule. It just variance is equal to the sum of the square deviations in the population.
Yep.
Okay, I see that on here. Okay.
So
I knew I saw that somewhere, but I didn't quite understand it. Anyway, yeah, okay.
which
right.
Does everybody understand?
Yeah.
Oh, what was the answer? The variance?
The variance.
The variance, yeah.
Okay. Mhm.
Okay, question 14. What is the standard deviation of these temperatures? And then round your answer 3 decimal places.
Oh, so we got to figure out all of that, right?
Right.
You got to do the whole shebang. Oh, geez.
Yeah.
I got 0.89.
Well, you're way ahead of me.
I got a 0.715.
Okay, I'll do it again.
Did you guys already do all of the boxes?
Yeah, I put in the Excel. Let me see.
You put it in there?
Yeah.
How do you do that?
Oh no, I mean I copy them, like copy and paste, copy and paste.
Oh. Is that what we're supposed to do with this?
I don't see why we can't.
So we're supposed to put those numbers in our little Excel?
And then you can just get the formula for standard deviation. No? Let's see. Is it these temperatures?
Wow. I understand that, but I didn't do that. I guess I was doing it by hand.
Oh. Oh no, I just copy and paste them on Excel, and it's faster.
Well, that is much faster. Is that what everybody's doing?
No.
I wasn't, but
By hand.
I
I
can.
must be really, okay. Well, that's much easier if that's how you do it. Okay, so I'm going to add these up. 0.027 plus 0.681 plus 0.81.
So you got the standard deviation, Raquel, is 0.715.
Let me see it. Yeah, 0.715. Did you get the same?
Yeah.
Okay. So what did you guys get?
0.715.
I did it by hand and I didn't get that, but that doesn't mean it's wrong. Yours is probably right because I did it by hand and then added them and divided by.
What answer did you guys get? Say it one more time.
0.715.
Okay.
17. I got 0.7.
Yeah.
0.715. Oh, okay.
0.715.
Okay.
So from the beginning, guys, we could have just put this in the Excel thing from the beginning
Yes.
without having to do it by hand?
Just for this, yes.
Well, that makes it much easier.
And we are allowed to use Excel and things.
Right.
It's all right.
Okay.
Okay, you guys ready to move to the next question?
Oh, wait, I gotta get back there. Hold on just a second. Okay, so 14.
Is
0.715.
yes.
Okay, all right. Okay.
Okay, question 15. Under certain conditions, the standard deviation can be negative.
That's false.
Yeah.
I don't think it can ever be negative.
No.
Okay. You ready for the next one?
Mm-hmm.
Okay. In the same study, the researchers placed thermistors in the 3 seals near the spinal cord and brain in the extradural vein. They placed thermistors in 6 other seals in their aorta, the largest artery in the body. Finally, they placed the thermistors in 4 other seals in their hepatic sinus. So the results from the study are summarized in the table below. So arterial, extradural, and hepatic. Which location resulted in the most consistent temperature measurements from one seal to another? Wouldn't that be the one with the lowest standard deviation?
Yes.
Well, that's what I thought, but then I asked my son, who's really smart, and he said that you have to, that may not be true because the sample sizes are different in each of the standard deviations.
Yep.
So,
We don't have a response that says we can't determine it or it doesn't apply. It just says which location is the most consistent, arterial, extradural, or hepatic.
from one seal to another.
So,
So I think,
based upon
what's
Yeah,
that?
it is true that it's not true in all cases, but in this case, the one with the smaller standard deviation also has a smaller sample size.
Mm-hmm.
So for this one would be true.
You think it's the 3 or extradural?
Yeah.
That's what I think. Extradural.
Okay.
So the standard deviation is smaller.
Well, it is, yeah. I just didn't know if you had to do another step and, divide like the sample size by the standard deviation and then you get different amounts. I didn't know. Yeah.
Well, I'm not sure.
it says a larger standard deviation means that the data are more spread out than the data with a small standard deviation.
And the most consistent temperature measurements. I don't know. We can try that. That's what I thought it was at first.
Okay, next
What do you guys
one.
think? Yeah?
I think
Okay.
extradural.
All right. I'm with you. So minimum, it would be 8.
Okay, so the number of hours students spent studying an exam are recorded. The data are represented by the box plot below. So what is the third quartile? 8.
It would be 8,
Mm-hmm.
right?
Yeah.
Okay.
What percentage of data lies between 4 and 8 hours? Note, the list of number as a percent and not a decimal. Don't include the percent sign.
Ooh.
50. 50%.
What percentage? Oh, yeah, because each of them is 25. So
Yep.
it'd be 50.
But put,
So I have a question. What's that?
it says, if the answer is 66%, then put only 66, not 0.66. Not
So we
as,
just put 50.
not as a percent sign. But just 50.
So I have a question on the box plot. So see the little I can't tell what that is. On 14,
Mm-hmm.
is that a 6? Do you guys see it on the box plot up there? Huh?
I don't know what that is.
I was just wondering, does that mean that there's some that are outlying out there?
Yeah, I think they represent like values that are very far from the mean, and that's
Yeah.
why they don't count them. Like
Okay. All right. Okay.
they're unusual. Like,
Okay.
mhm. But you guys, what did you say it was the answer for 18?
50.
50? Okay.
For number 18? Yeah. It's
Mhm.
50. Because it's 50%.
Yes. Oh. And why? Because it's
So it's asking for all what is between the 4 and the 8. And from 4 to 6 is 25%. And from 6 to 8 is 25%. So together it makes 50%.
Oh, okay. Thank you.
All right. Next one. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean, there are several contaminants that can harm the city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million, and values outside of this range are unusual. So we'll assume that it's the mean minus 2 times the standard deviation equals 1.59 parts per million, and the mean plus 2 times the standard deviation is 2.52 parts per million. It is reasonable to assume the measured nitrate concentration is normally distributed. Okay, so that is the 95. Okay, so estimate the mean and of the measured nitrate concentration in Rexburg's drinking water.
Okay, I need help with this one.
Yeah.
So
Okay,
I was like, what in the heck?
so
Got it.
so this is part of the 68, 95,
Right.
9.7 rule.
Okay.
So take your piece of paper and you're going to calculate. What is the mean?
So are you just taking the two numbers and dividing them? Or what? How are you figuring this out?
I'm not sure.
I'm not either. That's.
Yeah.
I was hoping one of you guys were smart and knew the answer or knew how to do it.
I have it.
Oh.
So I the way that I did it was this. So there's a difference. So there's a mean, and then 2 standard deviations less, that's 1.59.
Right.
And 2 standard deviations more, that's 2.52.
Mm.
So technically, there is, between the two quantities, there is a difference of 4 standard deviations from -2 to 2. So what I did is that I took 2.52 minus 1.59, and the answer is 0.93. Yes, 0.93. So that 0.93 is equal to 4 standard deviations. So I just divided it by 4, and the answer is 0.2325. That is 1 standard deviation. And
Holy moly.
And then I just did 2.52 minus 2 times the standard deviation, and that's the mean. I checked it, and it's right.
Wow.
So what's the mean?
2.055.
2.05.
Oh, I got that.
Oh. 2.
Okay. So explain that again. So
Yeah.
I got the mean.
Yeah, I don't know how the teacher would explain it. The way that I do it is there's 4 standard deviations. So from -2 to 2, that's 4 numbers.
Right.
4 standard deviations. So I subtracted 2.52 minus 1.59 to get the value of the 4 standard deviations, which was 0.93, and then I divided them by 4.
By 4. Okay.
And the answer was 0.2325. So that is 1 standard deviation. And then with the values that we have, I just calculated the mean, which is 2.055.
So that's the answer is 2.055?
That's the answer for the mean, yes.
Because what I did is I added those two together and I divided it by 2, and that's what I got. I guess I was lucky.
Yeah, I don't know. Yeah, I think that would do it. Yeah, I think that would do it.
Yeah, but then I don't know where to go after that, so on 20.
Well, if you have the mean, you know the mean, and you know that 2 standard the mean plus 2 standard deviations is 2.52, you just need to take the mean and subtract 2.52 and divide the answer by 2. And that would be your standard deviation.
2.055.
It's like solving for x.
Yeah.
Oh yeah.
Okay, so the mean we got is 2.055
Yes.
Mm-hmm.
for number 19. And then for 20, we're going to take that and estimate the standard deviation of the measured nitrate concentration. Is that
So we
correct?
take the, I think that's what she was saying.
Right.
So we take the mean minus the 2.52.
Yeah.
Is that right?
Yeah.
All right. 2. So I got negative 0.465. Oh, then we gotta divide, right?
Yeah.
And what are we dividing by?
By 2.
What is that for?
Because those are 2 standard deviations, and we need the value of 1.
Okay. So negative 0.233?
2325 is what I got.
But if we have to round it up.
Yeah. Yep. And we just disregard the negative sign.
Estimate the standard of the measured. Whew. All right.
So what did you get for the answer? It's negative as well?
No. No, standard deviations cannot be negative, so it's just, you just disregard the negative sign.
2, 3, 3. Because we got to round it up.
Yeah.
Right.
I know, I'm confused.
I don't know. This one was really confusing
Yeah.
to me.
So you got 0.233?
Yes.
Okay. That's what I got.
Hold on, I'm still trying to calculate.
0.233. 0.233. Still standard. Drinking water.
Oh, yeah. Okay.
So on the next question. That's what I was wondering.
You said you guys got 2.3.
Yes. For what?
You said you got 2.3 for 20?
I got 0.233.
Oh, okay.
Yeah.
I think I may have gotten that too. Let's see.
Is it?
Yep. 0.233.
Oh.
68%. Do you guys understand the next one? Are we on the next one yet?
Yes.
I don't understand it.
Okay, so you take 2.055, you subtract
Yes.
the standard deviation, 1 times the standard deviation because you're doing the 68%, and then you're going to add it as well.
You minus 1?
No. Okay, so I don't remember where the calculation is, but okay, so it's your mean plus or minus the standard deviation multiplied by 1. So it's just the standard deviation, and that
So
is
that's
your factors.
So that's the 0.0 or the 0.233,
Right.
right? Okay.
Yes.
And so we're subtracting.
And the last one is what I got. Are you understanding or not? Are you having a hard time?
I'm having a hard time. I can't see it visually.
Okay.
I mean, I can, when you've got the little, what are those things called? The little diagram where you can see underneath where they show like the 68% and the, from here to here.
So this is all we're doing. I'll put it in the chat box.
Okay, hold on. I got to look at you. Okay, go ahead. You put it up there. I'm going to pull you up here. Where are you? That's not where you are. There you are. Okay.
I'm here, I promise.
I see you. Where did you get the 0.23? Oh, okay.
Got it.
So you take 2. Okay, that's the mean. So it's 2.055 plus. Where did it go?
It's just like if you were to do like the 95 and the 99.7, you would multiply the standard deviation by how many deviations away they are. So since we're only 68%, it's only 1 standard deviation away. So it's just standard deviation. Then if you do the 2 standard deviations, it would be 2.055 minus 2 times 0.233 and plus. Does that make sense? And that would give you 95 percentile. And then the 3 times 0.233 will give you the 99.7 percentile.
Okay. So if we're trying to find the two measured concentrate, or the 68%. So I did the plus and I got 2.288.
Yep.
Correct? And then you have to do minus also?
Yep, and
Is that correct?
So that gives you the -1, and then that gives you also the positive.
Okay.
So, hold on, let me. Okay, let me share my screen and I can show you.
Oh my gosh. Did you guys hear that?
Yeah.
That was terrible. Hadley. Sorry, that's my son playing a video game. Hadley, be quiet. Oh my God. Sorry, guys. That's what happens when you have a 15-year-old. Hadley, be quiet. Oh my gosh. Okay.
So Does that make sense, Kathleen, or do you need?
I understand the first, I understand how you got the 2.288.
Okay.
Now, how did you get the other one?
Yeah, let me share my screen real quick, and I'll show you. Okay. Okay, can you guys see my screen?
Oh, I could see lots of screens.
Oh, of course. So, come on. That one down. Okay, can you see that now?
Yes.
Okay, so here's your -1. Here's your mean. Here's your +1. So that's why we subtract 1 and we add 1. Standard deviation.
Okay.
Does that make sense?
Yeah, so we're subtracting 2.055 minus.
Right, so, and they've even got it down here for you. So here's the mean minus the standard deviation.
I need that little thing right there.
If you just Google it, Google the 68, 95, 99.7 rule, it takes you right.
I need that little thing.
So
Okay.
I just Googled it. And that's
Yeah. Okay, cool. I've seen
and she
that.
said
So.
you can even just copy that and maybe put it in your cheat sheet.
Yes.
The cheat sheet we're supposed to have for the thing.
Yes.
Okay. All right, let's go on.
Okay. Hang on, I'm almost there. Oh, sorry guys for that little bit of sidetrack help
Okay.
I needed.
Good.
You're fine.
You're
Okay, so we're the last one.
Okay.
All right.
So the admissions committees for most Masters of Business Administration programs require a graduate management admissions test. As part of the application for new students, it's been shown that the scores of the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program in the School of Accountancy at BYU is 500, but it's rare for students with a score less than 600 to be admitted. So what's the probability that a randomly selected student will score above 542.3 on a GMAT?
Oh. So we have to find the Z-score, right?
Right.
Right.
You okay?
Okay. Score above the 54.
Right.
Okay. So
We're trying to find the Z-score.
0.3509. Okay, I got it. I got 0.3509. Or that was, yeah, the Z-score.
Yeah, and then you plug that in the applet,
Uh-huh.
and then just shade the right side because it's asking for the score above.
Here's my question. What was the C-score that you got?
I got 0.3509.
Okay. The thing is, what is the probability that a random selected student will score above 542.3? That's the mean.
Yeah, that's what I'm saying. You can't subtract the mean from the mean and get 0 up top.
Yeah. So actually, the C-score of the mean would be 0.
Yep. I agree with that.
The answer would be half.
Is 0.
5. Yeah, the answer, what's the probability? If you, and the normal probability template, if you plug in a 0 for the C-score, you will get a line right in the middle. And if you shade the right side, that's half, 0.5. That's the answer I put down.
0.5.
That's what I got.
Yeah, that's what I got.
I don't get it, guys.
Okay, so in the typical z-scores
Mm-hmm.
calculation,
Yeah.
it says value minus the mean. Well, the value here they want to know is 542.3. That's the mean. So you would plug in 542.3 minus 542.3 divided by the standard deviation of 120.54.
Mm-hmm.
So that's
Okay.
0 divided by 120.54, which is 0.
Right. Okay, I got that.
And then you plug that into your applet, and you want to know the percentage of students that will score above it. So you put
Mm-hmm.
0 for your z-score,
Mm-hmm.
and you shade, it's only half, so you would shade the top half, and
Mm-hmm.
it's 0.50.
I see that.
Does that make
So they're
sense?
just trying to be tricky.
Yeah.
Then. I don't like that. I don't like that. So 0.5. Okay.
It's 0.50 to like 0.50 or 0.500 or
Oh, 0.5. Don't we do 3?
just 50. Because it's the half.
Okay, so they want to know. Did you get it? Sorry.
Yeah.
Yeah.
Wait, I gotta find my place home. Where am I? Okay.
No.
Wait, no, what?
Thank you.
Oh,
Okay, so 22 is,
0.5.
okay.
So just
I
one
understand.
decimal place. 0.5?
0.5.
Okay.
Okay,
Okay,
so,
this one is 23 is what is the probability that a randomly selected student will score below 600 on the GMAT? So 600 minus 542.3 divided by the standard deviation of 120.54.
mm-hmm. I got 0.4786.
I got 0.684.
Yeah, that's what I got too. 0.684.
684.
Are we putting that incorrectly? So we're just shading the whole left side, even the middle?
Or below. Yeah. Let's see.
Less than.
Did you guys get 0.479 as the z-score?
Yeah.
Okay.
Wait. Oh, 0.479. Yeah, I got that.
Yeah, and then you'll just plug that in. But
Okay,
I'm always wondering if I shade them incorrectly, so.
So they want to know who will score below 600. So you're going to the left.
Yeah, so just everything to the left, including the middle, right?
Correct.
Right.
Okay.
so what is the probability that a randomly selected student will score 600 or above? So will you explain to me, because I get confused. The lines, what are the 2 red lines exactly
You mean 2 red lines.
on the normal probability applet?
Okay. So let me share my screen again. You can see it.
But like one is like the mean, right? Is that right?
Okay.
Not all
So
the way.
on here, can you see it?
Uh-huh.
So the first, let me get my cursor. The first red line right here. Oh, I have an echo. So this right here.
Mm-hmm.
So here's your mean in the 0. The 542. So this is 600. And my guess this is 500. Because that's the standard deviation away from that. So this we would do is we calculate using everything below. Everything below this.
So it's saying what? It wants to know.
So what's the probability that someone would score below 600? So we know that
600 or above.
deviation is 600. They want below 600, which is all this blue.
I thought it was 600 or above.
Now the question states. Sorry. Okay. It says, what is the probability that a randomly selected student will score below 600 on the GMAT? So our probability states 0.684.
Yep.
Yeah.
Do you agree?
I
Mhm.
Okay.
thank you.
All right. 24. What is the probability that a randomly selected student will score 600 or above? So this is where we can 600 or above.
So what was 23? Sorry.
23 was the 0.684.
0.684. Okay.
That was the below.
Mhm.
And then this no. What is the probability that a randomly selected student will score 600 or above on the GMAT?
Just get it right.
Yep, we're just going to shade just the right.
And then you get 0.1.
What did you get?
I got 0.316.
Okay. What I got.
What did you guys get?
For which one?
Let me see. Hold on. It's 24.
It's
124.316.
Okay. Are you guys? Are we on 26?
No, 25.
I'm sorry, 25. Yeah.
So 25 says find the GMAT score, type your response to the 10th percentile, and round to the nearest whole number. So if you go to the AppLay and you plug in 0.10, It's going to give you a z-score of 1.282. Then plug in that z-score in the equation and find the value. Did you guys get the answer?
I'm close. I'm getting there.
Yeah. I got 388.
Got 697.
I got 697.
For what number, sorry?
Number 25.
And I got 388.
I got 388 too.
Can you guys show me the formula?
So for Z, you plug in 1.282, and that equals minus 540.3 divided by 1.54. So Anita, how did you get your answer?
The 388.
Yeah.
So let me go back to that. 388.25. Okay, so what I did is calculate the z-score first. So I went to a normal probability amplet. And I put 0.10 at the top, at the area.
Right.
and that'll give you the C-score for the tile. So you just shade the left side, and the C-score is negative 1.282. Now, in the formula to calculate the C-score is here. It's x1 minus over the standard deviation. So where is it? That is the formula for the C-score, right? C equals x1 minus the mean over the standard deviation. So what I did is basically what?
So you did negative. Maybe that's the problem.
Yeah, I got negative.
Yeah, the C-score is negative because if you do the positive, that's the 90th percentile
Right. Okay.
instead of the 10th percentile.
Yep. Okay. So you got 388?
Yeah.
Okay, but now that makes sense. Oh, but for the next one, 90.
So then you guys got 697 for the 90th percentile.
Yes.
For number 26. Okay. Kathleen, are you with us?
Oh, I don't know if I am or not.
Hey, you guys. I have to leave because I have to be somewhere by 9. I just submitted the quiz. I got the last 2 wrong. And I will of the answers to them to your email. So if you're struggling, you can just like check what's wrong and what's right if you want to. Does that sound good?
Okay.
Sweet. Also we got 2 questions wrong. And those are question number 2 and question where is it? Number 13.
Oh. Okay. So it was just toothpaste for number 2. Sorry.
No, I think it was all of them. Oh no, yeah, you're right. Yep, it was just a toothpaste. Okay, I'm gonna screenshot this. What question are you guys on? 27. Okay. Okay. So there's 2 screenshots, and I put them in the chat. And those are the answers that I got right and wrong for the last questions that you guys have remaining.
Okay, thank you, Nita.
Yep. Let me see if I have number 13. No. Wait. Yeah. Okay. Well, sorry, I have to go. But thank you guys, and I will see you next week.
Yeah, thank you.
Thank
Yeah,
you.
I'll see ya. Bye.
Okay, guys. Okay, Kathleen, where are you stuck?
I still don't, I mean, I know how to get the z-score, and
Okay, so let me,
all the percentage things are really confusing. How you find the percentage.
okay, so let me show you. Let me write it out nicer because I'm sure you're going to be going, what the heck? But and then I'll share my screen too so that you understand where it came from.
Okay. I'm sorry if all you guys understand this and I don't.
Oh, it's all good.
Yeah.
That's why we're here.
And you have to listen.
Don't even feel bad. Plus, Kathleen, if I could understand the last 3 answers, then you could totally understand it.
Oh, I don't know. I think I understand this, and then I go through this, and it's like, oh my gosh, I don't know any of this.
No, you
Anyway.
will. You'll click. You'll click.
Okay.
Hold on. I'm writing it up as we speak. Okay.
Yay!
So tell me if you can see that. Hopefully you can.
I can see it. Okay, wait.
So the top one is
12.
number 26 and the bottom one is number 27.
Okay, wait a second. So 1.282 is equal to 42.3. You just went, where'd you go? Oh, there we are. 5.4, and then you do negative. Is that a U or a V? What is that?
I put V for the value because I don't like their little sign that they make you do.
Okay. So basically, we just take the Z number and we go backwards.
Let me show you here of the probability applet. Okay. 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 Sorry, I'm trying to get my screen to share.
That's okay.
It doesn't want to share. Okay. So here's your normal probability applet. Okay.
Mm-hmm.
So if you put in 0.10, it gives you the z-score of negative 1.282. Okay. So that's 10%, which is what they're asking for.
Yeah.
In
Okay.
number 20.
So 10% is on the left and 90% is on the right.
Right. So that's where we got the z-score from. And then if you
I got that.
do that equation, you'll get the answer to 25, which is the negative 1.282 equals V minus 542.3 divided by 120.54.
So the V that you're using, that's
like value. Like that's like trying to find X, if that makes sense.
okay.
Because we want to know what GMAT score corresponds to that 10 percentile. So the whole time they've been saying, okay, well, can you tell us what's the percentile that'll score this? We want to find that score now and know what the percentile is.
So you're taking the 542.3 divided by 120.54.
Correct. That one will be,
Because I didn't get 388, if that's what you're.
for number 25.
Yeah. So you take those two equations that you showed me with the numbers, right?
Yeah.
Okay. And so you take the 542.3 divided by 120.54. Is that right?
Well, then I'll show you my work in a minute. And then hopefully
Okay.
it makes sense.
Everybody else is going to be asleep by the time we get done. Mackenzie's going to sleep.
Okay, you ready?
Don't feel bad.
Okay. See my paper.
It's my own fault that I'm in my bed. So.
Next time I'm going to do that.
Kathleen,
Yes.
see this now. Sorry, trying to make it come in so you can see.
Okay, I see the top. So you've
Okay.
got the negative. Okay. So B minus, okay. So do you have to do it for each?
Yep, so you're gonna multiply both sides by the 120.54. Then you're gonna add the 542 to both sides. And you should get the 387.7677. Making it 388. Does that make sense?
Yeah. Clear as mud. Okay.
Okay. And then if you do the same thing but have a positive instead of a negative, you'll get the 697
Okay.
for the 90%.
Okay.
Okay.
697. Okay.
That makes sense.
Mm-hmm. Thank
Okay.
you.
Yeah.
Okay, what are we on?
Number 27.
Okay.
So find the first quartile of the distribution of GMAT scores. Round to the wholest number.
Whole number. Okay.
How do you even find the?
So how do you do this?
Okay, so the first quartile we know is 0.25%, correct?
Yeah. Mm-hmm.
So you go to the
20.
and you put in 0.25.
Oh, okay. So it's just like doing those other ones, but doing.
Right.
Okay, got it.
Oh, you go to the area and put 0.25?
Yep, and then it'll give you the z-score. So we want
Right.
negative 0.674 z-score.
Mm-hmm.
And we're going to find the value again. Like, make sure I got it. I got 461.
Say that one more time.
I got 461.
Me too. Yay.
For the C score, did you get like negative 0.674, right?
Yep, negative 0.674.
Okay.
And then we know that. I'm sorry, what?
And then you just try to find X.
Yep, you plug it in. Yep, just like we did in the previous problems.
Okay.
And then the third quartile, would that be 75?
Yep, and so it's just the opposite of the 25. What are you doing, Kathleen?
Don't know. Oh gosh. I'll just have to study it, you guys. I'll have to study that part because I don't know why I'm having such a hard time. I think it's just the equation and going backwards that the algebra or whatever.
Yeah, but you know what's good about the test though is we get a cheat sheet. Like you just get one page, and you could probably write down that equation in there.
Yeah,
So
I can.
so you'll be okay.
Okay, so wait a minute.
So
So what'd you get for 27?
461.
Okay.
So each quartile has 25%. Response to 25%.
Okay, Kathleen, how you doing? How you doing?
So, well, I'm putting in the 70, we do the 75% now.
Yep. So it's going to be the same Z-score as the 25 percentile, but a positive number. So it'll be 0.674. If you want to, I have it here. You can look.
Wait a second. Oh, there you are.
Does that make sense?
So you take the 120 on the bottom and you're multiplying it times the 674.
Correct. You multiply it by both sides.
It's been a long time since I've had algebra. So you multiply that, and then you have that equals that. And then how do you get the 623? Oh, is that 623?
You add the 542.3 to both sides. And then that singles out the V on the one side. And do your answer on the other side.
Okay. I got it. Okay. I think.
Let me know if it would help you if I wrote out each step individually. I can do that. It's not.
I don't know. Where am I? Okay, I'm just trying to get back to my. There we are.
Green.
Okay. Yeah.
Okay.
So 27 is 461 and 28
is 624. Is that what you guys got?
Did you say 624?
Yes.
Yes.
Yeah, 624.
Okay. Okay, what are we on, 29?
So consider a simple random sample of n equals 15 students taking the GMAT. So what is the mean of the distribution of sample mean scores for all such samples? So round to the nearest tenth, 1 decimal place.
Hadley, you're gonna get in big trouble. You didn't hear all that, you guys.
Okay, so these three questions, this is where I have a hard time on the simple sample distribution.
Mean scores?
Yeah, just have trouble.
So is this where we do the, I'm trying to remember.
The
And we're doing the square root and everything, right?
right, the standard deviation, so 120.54 divided by the square root of 15.
Oh,
Hold on, I can't see all this stuff. So we're taking,
Wait,
For
hold
number
on.
29,
okay. Okay, so start over. So the z-score is equal to, what did you say? The mean? I'm trying to think.
So hold on. I know we had a question exactly like this on one of our quizzes last week.
yeah.
Hold on, I'm going to look it up.
the mean that they give us right, like already that 542.3.
Yes.
That's the mean.
I know we thought it was harder than it really was, and it was just the 542.3.
Yeah.
That's the mean.
What is the mean of the distribution sample mean scores?
Still looking, so hold on 1 sec.
What is the mean of the distribution?
Okay. Okay, so it says, this was one of our questions that we did here. I'll share my screen so you guys can see it too. Okay, so this was a quiz we took last week, and it says, for number 11, what is the mean of the distribution of sample means for all possible sample sizes, samples of size 81 that could be drawn from the parent population? And then it says up above here that the mean where am I going? The mean GPA of BYU students is 3.5. That was the answer, the actual mean. So for our question, number 29, it would be our mean, which is 542.3.
Okay.
Question 30, what is the standard deviation of the distribution of sample mean scores for all such samples? Where am I going? And then here, we stated what is the standard deviation of the distribution of sample means for all possible sample sizes of 81. So my guess is we took the standard deviation and divided it by the square root of 81. So what we'll do in this one, for number 30 on our quiz today, is we will take the standard deviation of 120 and divide it by the square root of 15.
Yep.
Does that make sense?
Yeah.
It's Yeah, I got
So-
Standard deviation 120. Okay.
mhm,
So you're saying for 29, the mean is just 120.54, right?
For number 29, the answer is the mean of 542.3. That's the mean up here. Where's it?
mhm.
The mean of 542.3.
Oh,
So the standard deviation is 120 divided by 15. Is that what we said? The
Yeah,
square root
but
of 15?
it's 120.54.
The only thing that bugs me is how it says, what is the standard deviation of the distribution of sample mean scores for all such samples and not just the sample of 15? We still think it's that. Yeah, probably.
Mm.
What did you guys get? I got 31.123.
I did too.
Yeah, me too. 31.23.
30 what?
31.12.
123.
So I got 30.9917. So I don't know what I did wrong.
Did you carry out your square root of 15 or did you?
Oh, probably not.
Yeah, don't
Probably
really.
not. Okay, so it's 32. What did you say?
32.123.
Yeah, I didn't do all those numbers. That must be why. Okay.
Okay. What is it? Are you ready for number 31?
Yeah, I am.
Okay. What is the probability that a sample mean GMAT score for SRS of N15 students will be greater than 600? This is where we take this, we need to find the z-score
Mhm.
equals 600 minus 542.3. Divide that by 120 divided by the square root of 15. Mhm.
540.
Remember not to round yet.
Mhm. Mhm.
Okay, I got 0.031.
0.03. I got 0.032.
Do we have to plug this into the applet?
Yes,
Point
your score.
Get around.
I'm getting there.
What did you say?
Yes, your C-score. You
Yes.
plugged it in the applet.
Okay.
And then you just shade to the right
Mm-hmm.
only.
And you got 0.0319?
Yes, but
Well,
rounded is
0.032.
0.032.
Mm-hmm.
Awesome.
Wait, say that again. I got 0.0313.
Yeah, you're right. Just
Is that
run,
right?
Mm-hmm. Just run it through to 3 decimal places.
Yeah, okay.
0.032.
0.032,
Mhm.
right?
Right.
Why would it be 2?
Because it's rounding.
Because I got 0.0313 on the area.
Oh, what did you get for your Z-score?
I got 1.862.
I got 1.854.
Oh my god.
Yeah, I got
It's
this.
You just have to wait to round at the very end.
Yeah.
I thought I did. So 1.854.
Yes.
Okay, I got it. 032. Okay, I got that.
Okay.
So Nitzia
All
said
right.
that number 2 and 13 were wrong, right?
Right.
Let me see them. Number 2.
Oh crap,
So
I didn't go back and
13.
change number 13. And I submitted it.
Oh, you did?
Yeah.
So it's not the variance.
Nope, it
On
is
13.
not the variance.
Hmm.
Oh, did you submit it already?
Yeah, I submitted it before I even realized that. It's
Oh,
okay. I can go back and change it
okay.
if we figure it out. Okay, so it's saying that the quantity is equal to the sum of the numbers in the squared deviation, or what quantity is equal to the sum of the numbers in the squared deviations column. Where is that lesson?
Let's see.
Oh. Does anyone remember what lesson that was? Number 3? Number 4.
The mean and variance and discrete random value. It's number 4, I think.
Okay.
I think, if that's what we're looking at.
Yes.
Mhm.
I saw that and I should have just kept reading it. Finding the mean of a discrete random variable. I think it's lesson 5. Ha, here it is. Variance. The variance is the square of the standard deviation.
The square standard. In what lesson did you find it?
I found it in lesson number 3.
Thank you.
Yeah. I'm like, I know I saw it. You guys, I think it's none of these is correct.
That's what I think.
Yeah, I think it's none of these are correct.
What
Who wants to be the guinea pig and try it out?
I will.
I
I'll
can.
try it.
Because we can always go
I'll
back.
do it.
Let's see the sum of the numbers in the square deviation.
Okay, I'm submitting mine.
Okay, let us know.
I'm the guinea pig. Okay. 1, 2, 3, 4, 5, 6, 7 is right. 8 is right. 9 is right. 10 is right. 11, 12.
I'm going to stop the
That's
broadcast. guys.
correct. None of these is correct. That's right.
Okay, awesome.
That's right.